So for each of these graphs, we want to state whether it represents a function. So what I want you to remember is that for a function, for each input, there can only be one output, meaning you need to be able to write it as f of x equals some y. Meaning when I plug x into my function, I know exactly what y is going to come out. So let's look at this one, for example. If I plug in -4, what's going to come out? Is it going to be -2 or +2, right? You can't, if it's a function, each x value only corresponds to a single y value. You can't have this, oh, sometimes -4 goes in, when -4 goes in, sometimes -2 comes out, and sometimes +2 comes out. No, or whatever it is, +4, right? Right? You can't have two different y values that correspond to the same x value. So this is not a function. No. So I'm going to write no. Okay. And the trick is there's something called the vertical line test. Okay, so I made a vertical line. It's going to come along with a little bit of white because I couldn't figure out a better way to do it. But basically the idea is you move your vertical line. Okay, and obviously I have an actual vertical line, but you're going to do this in your head or with your pencil. And if your vertical line hits in more than one spot, it's not a function. Okay, so this is not a function because you can see my vertical line hits in more than one spot. Okay, because that means if your vertical line hits in more than one spot, you've got two y values, corresponding to the same x value. Okay, let's skip this one for a second. Here, my vertical line is passing without a problem, right? You see that? There's no place on here that the vertical line hits two spots. So yes, that is a function. Okay, let's move over down here. I know we skipped one. We'll come back to it. Oops, I'm moving the wrong thing. Where's my vertical line? There it is. Nope, that's not it. There it is. Okay, look. Vertical line hitting in two spots, that's a problem. Okay, so that's not a function. Okay. All right, let's look at these ones with the dots. Okay, so come on, vertical line, where are you? There you are. Okay, so I mean, maybe the vertical line doesn't help so much with this one. Okay, if I kind of did this vertical line here, this one, there's no problem, right? There's no two different y values that have the same x value. Here, no problem, right? I don't have two different y values with the same x value. No problem here. No problem here. So yes, that is a function. Okay, now let's look here. Right here I have a problem. Like if I put my vertical line right here, it covers them up, so I'm not going to do it. But here, sorry about that. Let me draw a vertical line. Right, that vertical line goes through 2 points. Why is that a problem? Because it means this x value, 5, goes through, if you plug in 5, right, does f of 5 equal 1? Or does f of 5 equal -1, right? It can't be both. So that means that there is no f of 5 because it's not a function. Okay, so now coming back to this one, you need to know what an open dot and a closed dot mean. So an open dot means there's no point there, that you can kind of get as close as you want, but you never actually hit it. So let's say this is at -1. This means that like you can do like -1.1111 or -1.000001, right? And that's fine, but there's no actual point here. Okay, so because it looks like, oh, maybe there's kind of 2 points in the same spot, but no, this open dot means that there's no actual value here. So it's fine that like if you plug in -1.0002, let's say, y comes out to be -1, but if you plug in exactly -1, y comes out to be 0. Same thing here, because this is an open dot, it means there's no actual point there, so this actually does not create a problem, because there's no point, there's no value here, but there is a value there. So yes, this is a function.